microphones. So just that, yeah, there will be time for asking questions. So we dedicated time, and yeah, there will be a chance. So I will just share now the presentation that I can share just a second. Yeah. So I will quickly go just to the agenda, which we have in the scope of this webinar. And yes, we are starting, of course, with the introduction to the OPTAIN project and goals of the webinar, and then with the introduction into modeling in the scope of the OPTAIN project. And then we will be focusing on the challenges which we actually had in the scope of the project in regards to the modeling and how we tackle those. So the challenge 1 is how to be sufficiently spatial with your process. Then the challenge 2, how to prepare inputs and overcome data scarcity. The challenge 3, how to be sufficiently detailed with your crop management. Then there will be 10 minutes for questions and answers. And we will then continue with ensuring reliability in your model results, and also challenge 5 and 6, how to be sufficiently spatial with your retention measures, and how to optimize the allocation of natural small water retention measures for multiple objectives. And then one more question and answer session, and then we will be actually wrapping up and closing the webinar. It is a quite tight schedule, I do have to say, but we believe that we will have time to dedicate time to everything so that you will be able to actually have this overview of what was done in the scope of the OPTAIN project regards to modeling. So I would also kindly ask my colleague, Gabi, if you could please share the poll now. Please, in the chat, yeah, you see actually the poll, and please, if you can reply to those questions, just that we know where are you coming from in regards, yeah, your background. We will, yeah, have around 15 seconds for this. Just that colleagues actually have an overview. To whom are we presenting? Since this is, as you know, quite a technical, quite a technical webinar, but it is also adapted for the ones who are not coming from the modeling world. So you will be also able to follow, just that you know.
Hopefully.
Yeah, hopefully. We tried, we did our best. So we will stop now with the poll, although we have, yeah, 77%, but yeah, let's wait for a couple of seconds. Yeah. And yeah, now we will be ending a poll, and just to share results. Yeah, if you can see, you see now the results. So yeah, as you can see, there are most of the people, so 50% of the people are coming from the modeling world, more or less, I mean, actually, exactly. And the others are not involved in the modeling, but would like to hear and learn more. So this is good. Nice. Yeah, and just before I give the floor to my colleague Micha, I will just also introduce you with my colleague Brigitta Sabo, who is she will be one of the speakers, but also co-facilitate this webinar with me. And she is actually a senior researcher in the Department of Soil Physics and Water Management in the Institute for Soil Sciences, Center for Agricultural Research from Hungary. Her research activities focus on soil physics, soil database construction and harmonization, prediction of soil properties at local, regional, and continental scales. And she is actually involved in national and European soil database constructions in the scope of the OPTAIN project. She actually leads one work package on data retrieval and covering missing data for environmental models. And she is also a lead of one of the case studies, since we have 14 case studies in the scope of the project, and you will be hearing now very soon a bit more about the project itself. Just before we get into the modeling, also from my colleague Michael Strauch-Helmholtz, who is coming from the Helmholtz Center for Environmental Research from Germany. His research interest is in the impact of land use intensity and the landscape configuration of water-related ecosystem services, agricultural production, and biodiversity. He is also working and explores the trade-offs and synergies among different ecosystem functions at the catchment scale and uses tools in the field of integrated process-based watershed modeling. And also multi-objective optimization of land use allocation in the scope of the COMOLA. Yeah, so he is also one of the work package leads to the work package of the optimization of natural small water retention measures, and also a lead of one of the case studies in the scope of the OPTAIN, the one from Germany. So yes, giving the floor now, Micha, to you, and then Brigi will continue.
Thank you, Ivana. Shouldn't you stop your sharing?
Yes, I will.
Yeah. Thanks, Ivana, and thanks also Global Water Partnership facilitating this webinar. I want to start with a very brief introduction into OPTAIN, just for those never heard about the project, and then mention the goals that we want to achieve in this webinar. OPTAIN stands for Optimal Strategies to Retain and Reuse Water and Nutrients in Small Agricultural Catchments. So it's not the large catchments we are looking at, but we have several catchments across Europe, and this is a quite huge EU project coordinated by the U of Z in Leipzig. Martin Volk is the coordinator.
Micha, just say you are not sharing the presentation.
I'm not sharing. Sorry. Yes.
Now it works.
Now you should see it, right? Yes. So it's a quite huge EU project with many partners, 21 partners from 15 countries. And we have also 14 case studies, and each of the case studies doing the OPTAIN workflow. We have in total 7 million euros budget, and the duration was 5 years, or is 5 years. We are now getting to the end, but we still have more than 1 year left. In OPTAIN, we have a fully harmonized approach across all case studies. So each case studies, for example, forms a multi-actor platform, local stakeholders, and together with them, we do a scientific journey around natural small water retention measures. This is the central element of the project. We identify potentials and constraints in each catchment, model the performance, environmental performance, but also economic performance, and carry out a multi-objective optimization of the allocation of measures. And this part, modeling and optimization, is what the webinar is about today. But we also want to derive in each case study some recommendations, and we want to feed our results and tools, methods into a learning environment, which is hopefully useful, not only for researchers, also for practitioners and decision makers. Just to give you a little idea what we mean with natural small water retention measures, and we often use this super fluffy abbreviation NSWRM. Here is a more or less complete list of the measures we are looking at. We have measures where we just change the land cover. We do a greening, like riparian buffers, or crust waterways on erosive slopes, or edge of field filters, hedges. Then we have measures where the morphology and the drainage system will be changed, like ponds or constructed wetlands. We have also measures, although they are hard to model, where hydromorphology is changed along the channel system, floodplain restoration, for example, and then, of course, changing the management, crop management, soil management, for example, reduced tillage or no tillage, or applying cover crops. And each case study is not looking at all of those measures. They all have their own relevant measures. They decided with stakeholders which are relevant, which are most promising in the catchment. Here's an example what we do in the German case study. You see it's just like 6 measures. And those measures are then documented. If they already exist in the catchment, we look for nice examples and we document it in WCAT. This task is done. You can look into WCAT also for the measures documented in OPTAIN. And then we want to model their performance. Specifically, we look for soil moisture, surface runoff, stream flow, but also at nutrients and sediment. Yeah, both what happens on site in the field, but also then in the river. And we also model economic parameters, which are based on surveys and stakeholder knowledge. What are the costs of the measures, for example, or production costs in agriculture? And then we want to optimize the allocation, analyze trade-offs, and identify solutions together with the stakeholders. What could be a desired situation, given that stakeholders have different preferences? And in the end, we do some policy recommendations. So, but today we just focus on the modeling stuff. And what we want to achieve is that you get to know our approach, that you have a really good idea what we do in OPTAIN, and that you are also aware of the most relevant and also the new things, the innovative tools and workflows which we developed, why we developed them, and how you can use them. Yeah, we really want to inspire you to use them, and hopefully it will be interesting for you. So, and with this, I think I give the floor to Mikołaj.
Yes, but before Mikołaj will start, I will introduce him. So Mikołaj Piniewski is an associate professor at the Warsaw University of Life Sciences in Poland. He's an expert in process-based hydrological modeling, water resources management, and analyzing climate change impacts on hydrological processes. In the OPTAIN project, he's leading the work package, which is on the environmental modeling. So yes, please, Mikołaj. You are muted.
Okay, yes. Hello, everyone. I would like to give a very quick introduction into a more technical part that will follow. And as we could have seen from the poll, we have very diverse audience with modelers mixed with non-modelers. So it was smart from us that we planned at least a couple of slides maybe dedicated more on general level. So let me start with it right away. And referring to what Michael was presenting, this part refers to the modeling, the environmental and socioeconomic performance work package of the OPTAIN project. For non-modelers, why do we need models? My preferred answer is that we don't have the capacity to monitor everything we would like to, the environmental phenomena, both in time and space. And in this scheme, you have actually six types of services that the models deliver to us. And I think that in OPTAIN, we are mostly, each of them plays a role, but we are mostly focusing on using the models as a tool for simulation to answer the what if questions. What would happen to water quality if all farmers start applying catch crops, for example, but also a tool for understanding, for better understanding of hydrological processes, because we are working at a quite fine scale compared to many other model applications. The model that we selected to use already a while ago when drafting the proposal is called Soil and Water Assessment Tool, and it's among the most popular models in the world working with water quality and water quantity altogether, developed in the United States for over 45 years. It includes a comprehensive simulation of land phase processes, but also in-stream water quality, and is a continuous time working with daily time step. So plotting the bottom left is the scheme is showing the major hydrological processes that are included. Similar schemes can be shown for nutrient cycles, in-stream processes, and so on, but we don't have time to go into so much details. I would like to mention that for a couple of years, there is a new restructured version called SWOT Plus that has several new important features that well, improve the overall quality of the modeling, connectivity, decision tables, for example, and that SWOT Plus is now transitioning into a true community model with the code available on the GitHub platform. Now focusing on OPTAIN, what we are actually trying to achieve with the SWOT Plus model. Well, in first place, we are interested in estimating the effectiveness of different retention measures on the field scale. So this is a little bit more than many other applications are doing, just looking at the catchment outlet, what would happen. We are really looking at the field scale. Apart from single measures, we are interested in the effects of multiple measures acting all together, different combinations. Then we don't only look at field scale, but also use the aggregated catchment scale outputs to quantify these effectiveness. And another highlight is that while in first stage we are looking at the measure performance under current climate, we're also interested in performance under future climate. How do we want to achieve this? As Michael already said, our approach is fully harmonized, or maybe as harmonized as it can be pragmatically. So we want to represent landscape features that we call objects and their parameterization across all case studies in a harmonized way. We develop new tools to ensure sufficient spatial detail, for example, in the land use maps, but also complexity of agricultural management in our model setups. And we develop new scripted workflows to ensure transparency, but also facilitate comparisons between different catchments. So what are the three main requirements for our model setups in OPTAIN? For those not familiar, hydrological response units are the basic modeling units that are used in SWOT. So they are composed of certain land use, soil, and slope class. In our approach, we want HRUs to be representative of individual fields with the crop rotations and associated management, as you can see on this example picture. The second condition
to allow, you know, at the 6 minutes.
Contiguous routing between all land and water objects, And the third one is to allow for spatially explicit representation of selected structural measures at HRU level. So the second and the third will be discussed and in much more detail in the upcoming presentation. Our workflow consists of several steps, starting from a preparatory phase with input data preparation, model setup, and then the model testing phase, in which we also include soft and hard calibration, and the what-if simulation phase with various scenarios to be considered. And the tools that we developed and that will be discussed in the further part of the seminar are associated to different steps of this workflow. So you will get more familiar with them during the next presentations. And this brings me to a reminder of the agenda, what will follow, and again, the tools that we will discuss next to the challenges that were framed for the presentations. Thank you, that's it from me.
Thanks a lot. And now Michael will continue with the first challenge, which is how to be sufficiently spatial with our processes.
Yes. So some things I will repeat that Mikołaj just presented, but if you really want to do the things as we want to do in OPTAIN, to look at the field scale effects, you have to be sufficiently spatial with your processes. The model has to be sufficiently spatial. And you've learned we use the SWOT Plus model. And let's just have a look how SWOT Plus is usually structured spatially. There are different objects, different units. For example, there are land objects, often called HRU. Mikołaj mentioned it, but usually they are just representing a certain land use, maybe plus soil and slope combination. Could be pasture, HRUs, or urban or forest, or some on agricultural land representing some crop. And these land objects are grouped to landscape units. And then we also have water objects, like, for example, channels, or ponds, or reservoirs. And each of these objects in SWOT Plus, they have specific hydrologic functions. And there are also fluxes between the objects simulated in SWOT Plus. You can define, for example, what should go from one landscape unit to a channel, the percentage of lateral flow, surface runoff, or subsurface flow. Maybe 75% of it are sent to the channel, the rest goes into a reservoir. You can define something like that. Yeah. And to be a little more illustrative, this would be, for example, a landscape unit 1, representing the upland. And then you have another landscape unit, the floodplain, which is located at the channel. And you then have these fluxes you can define from landscape unit 1, something goes directly to the channel, and maybe the majority of the flow and nutrients go into the floodplain from the upland. And then from the floodplain, maybe 100% of the lateral flow is sent to the channel. This is how SWOT Plus usually does it, yeah? And the HRUs we talked about, the land units, you see here. The outputs, the problem is that within the landscape units, the outputs of all HRUs are lumped together, and then they are routed. And also HRUs, like this HRU4, maybe this is representing some cropland. HRUs are normally fragmented. They are multi-polygons, yeah? Everywhere where this land use, slope, soil combination happens in the landscape. So, and this is absolutely useless for OPTAIN because we want to have a more detailed picture. For example, we want to have such situation. We want to consider different fields and also there's green elements around the fields. Those can be typical retention measures. And if it's a situation like that, that maybe there are some hedges or buffers around some fields, but then there's also here a gap between a hedge. What would happen if we close this gap? This would be the resolution we need in OPTAIN. And therefore, HRUs need to be in OPTAIN self-contained units. And the outputs of the HRUs should not be lumped within some greater unit. The outputs should be directly sent to the neighbor objects, routed through a cascade of HRUs until it's being fed into the channel. Yeah? And our solution for that is the SWOT Builder. The SWOT Builder so far is an R workflow, an R script specifically developed for OPTAIN. And you can, for those that know SWOT Plus already, you can see it as an alternative to Q SWOT Plus. This is how you begin setting up a SWOT model, yeah? And the input data you need, if you want to use the builder, you need to provide some vector layers as shapefiles, point source, location, channel network. You need to prepare a land use map. Should be quite detailed, the land use map. Should also include those small structures maybe that could represent retention measures. And then you need raster data, a soil map, including also a database with soil parameters for this soil map. And last but not least, to calculate the connectivities among the objects, we need a DEM, a digital elevation model, ideally in high resolution, 2 or 5 meters. Then the SWOT Builder, if you run it, it would calculate first the connectivity among surface water bodies. Provide a channel network. Water objects will be taken from the land use map. And then you need to tell the builder what is the outlet channel. And then it will back propagate how the channels are connected in the network. Yeah. So this way you can allow the channels feed into reservoir, could be even multiple channels. It could be also that there's no inlet into a reservoir, but the surface water bodies are connected if there is a channel. And then the really, really important part is to calculate the connectivity among land objects. The land layer is taken and the elevation raster, and then the routine routes over each, or it iterates over each land object. For example, we have this small part of a crop, of an agricultural field. Maybe this is the gap between the hedges. And for this land object, we apply a buffer, and then we look at the flow accumulation from the DEM. And we also calculate the flow direction at all the edges. Where would the flow go to? Yeah. Flow accumulation plus flow direction. When we calculate the net sum of the accumulation, we know then, okay, 80% goes into this polygon, and then the rest, 13% goes into the other neighbor. And in this way, we do it for each land object and calculate the connectivities. How to use it? So far, it's not an R package. We will push Christoph, who developed the thing, to publish it as a real R package so far. It's just a workflow, but it is included in our full OPTAIN R workflow, and this is publicly available. So this is what I recommend you to do. And when you download and unzip the workflow, you will get something like that. These are all the files you get. First of all, you have to prepare your input data. And for that, you can look into the example data, which are provided. Same format, but for your catchment. And then you open the R project file. You, within the in RStudio, and in RStudio, then you open the settings R file. This is what you have to do first. There is a SWOT builder section in this setting file, and there you just have to adjust the paths to your input data, and a few more things you have to define. What is the channel outlet, blah, blah, ID. And then you can actually run the script, set up workflow R, run it until line 42, and the whole SWOT builder thing will go on. Most of the time you will get errors, but Christoph was very smart. Most of the errors, I think, he catched already, and there will be some useful advice what to do, why this error happened. Follow the message, try to fix your data, try it again. If you cannot fix the problem, drop an email. Maybe if it's published on GitHub, it's better to use GitHub to post the issue there. As a result, you will get a basic SWOT Plus setup with all the connectivities defined and without infinitive loops, because this can of course happen, yeah, with all those connectivities, but the builder will take care that there are no infinitive loops. And if the builder cannot solve it, he will tell you, and then you have to go back and change something with your spatial units. Maybe split some polygons in the land use map. It's a basic setup which needs further input data supply and more parameterization. And for that, you have, I mean, as an SQLite database is the result of running the builder. And this you can use. Import into SWOT editor. Then you do it the normal way you do it as a SWOT modeler. Load in your other inputs like weather data, or you have it already, the setup workflow, yeah, the full OPTAIN workflow, just continue with this workflow. And I think that's it for the builder and the first challenge. So
Thanks.
questions later, and I will pass to Brigitte.
Okay, so we go on with the second challenge. This will be presented by myself and by Sveinjonas Plunge. Sveinjonas is a research scientist. He works in the Warsaw University of Life Sciences in Poland with Mikołaj. He is an expert in process-based hydrological modeling, and he's expert in data science and GIS. So let's go with the challenge. So after you set up the SWOT builder, or even before, you have to prepare the inputs, and you often face the problem that you have missing data. So we addressed this in the OPTAIN project. So just a fast overview about what is the input data required for the SWOT model. So you need data for the calibration and for the base model setup and advanced model setup. And I don't go into details, but just highlight those input data which we addressed in the OPTAIN project. So one of the most important data we need in OPTAIN is the land use data, and not only the main categories which is usually used, but we have to specify the arable land. it is important because we would like to assess the efficiency of the measures, and many measures are management related. So this is why I connected this kind of input. So if we can provide more detailed data on the arable land, so we know the crops which are grown on the field, and we know it in a time series way, since we need it for a longer period, then we can specify the soil management data. So then we have the most important input to assess the measurement effect on the water quality and quantity. Then another part which we addressed is to cover missing soil data, because most often the case is that we might have the basic soil input data, but we do not have the more specific ones, some physical and chemical properties, which I will show you later. And we also address the atmospheric deposition, because usually there is no data available specifically for the case study you want to model. First, let's see how we solved the derivation of time series crop maps. For this, we worked out a crop classification method. This method needs a local crop data set where you know where which crop was grown in a specific year, or if you do not have this local data, an option is to use the Lucas data set. Of course, it has some limitations, but I will not go into detail now. Then you need the field boundary map, since we want to analyze the management, so we have to know the area of the fields. Then a local land use map is needed, or if it is not available, the Corin data set. And the Sentinel-1A and B satellite radar images are used as a predictor to predict the crop data. The method was derived on the Google Earth engine, and we applied this prediction method on those case studies where we didn't have time series crop maps. Of course, this has some limitations. So to finalize the crop maps, we considered the local or regional crop statistics, and we also contacted local farm advisors, farmers, to get time series data as close to the reality as possible. This is an example for the derived time series crop maps for 3 years for a Hungarian case study. And here are some examples how it can support our modeling. So if we know the crop, then we can assign specific management practices to it, which is very helpful during the modeling. Then the other input data we addressed in OPTAIN is covering missing soil data. So here we were dealing with physical and hydrological parameters and the soil nutrient content. From the soil nutrient content, we could address the phosphorus content, not the nitrate related one, because this is very challenging to predict. It is highly variable in space and time. So we stayed with the phosphorus content. And why we addressed this, because it was important in OPTAIN to perform all the modeling steps in a harmonized way. So all the methods we derived here were provided in a protocol for the modelers. Then a short overview, some info about how we selected the methods. So what we were in the literature, from the literature, we selected those methods which are which could be used in Europe, so in this pedoclimatic zone. And if there was a data set available with measured data, then we assessed the prediction performance of the selected methods. If no measured data was available, then we used some data, available data for comparison, to see how feasible soil properties are given by the equation if we compare it to remote sensing data or to other maps or data sources derived by others. And this is a summary about those soil properties which were addressed. So we predicted the effective bulk density and the porosity. Then the soil hydraulic properties. First we predicted the Fungenuktan parameters, then from those we computed the field capacity, the wilting point, and the saturated hydraulic conductivity, and the available water capacity. And with the field capacity, the albedo can be computed. Then we showed a possibility to compute the soil erodibility factor, but highlighted also that there is a European map available, and discussed in a paper in which situation which method would be used. And then we described also how hydraulic soil groups were derived in our project. I thought to highlight a bit the method which we derived to compute the ozone phosphorus content of the topsoil, because this is not frequently used as an input in the models, because it is not an easily available soil property. So here what I would like to show that there is a European map available, which we mapped or used for a Hungarian case study, and compared with our method. And our method is based on the Lucas topsoil dataset, which includes measured data on ozone phosphorus content. This is like a mean statistics based, so every land use, for every land use we assigned the geometric mean of the ozone phosphorus content based on the relevant Lucas dataset. This is described in a document, what we mean by relevant. And then if you have measured data for specific fields, then of course you replace those polygons with the measured data. And here I collected all the tools we derived. So the time series crop maps are available for Zenodo. I mean the script to derive it, which you can use in the Google Earth engine. Then here I provide the availability of the pedotransfer function, a prediction method to derive soil hydraulic properties. There are two possibilities to do it. Then we highlighted that you have to be aware what kind of sensed clay content is used. So if not the right one, please be aware that you have to harmonize it. And here is an example on this Zenodo link. Then this is the Zenodo link for the phosphorus content mapping. And then the most important methods has been built into a SWAT prepare air package, which will be presented by Svajunas. And just highlighting the most important documentations, you will get these slides after the webinar. So just telling that there is a protocol and there are two papers related to this topic. And now I give the floor to Svajunas.
Hi, everyone who joined this webinar. I hope you can see my presentation. Just let me know.
It's coming.
Coming? Okay, it might be slow.
Yes, yes, now it's visible.
Okay, great. So just continuing from what you, Brigitte, told and Misha as well. I think the main idea of this webinar is also we have many challenges in this project. We develop solutions and we really want to share them. So you can benefit maybe in your work, or you get some ideas how these challenges can be overcome. So this is a part of the input data, and of course, Brigi mentioned a lot of how we overcome the scarcity of the data. I would like to also mention other things, because we had a lot of problems with the data and a lot of different headaches. So this is what probably most of people who are in modeling and they're setting up the models, they are facing some problems with accessing data, also different water quality, not water quality, different data quality questions. And when you don't know, can you use this data? Can you trust this data? Also, how to prepare different parameters for when you get some data, but this is not directly translatable into model parameters. A lot of manual work, because you need to clean data, find all these different bugs, and this is also, if you need to repeat it, is a lot of how to say space for errors, and dealing with different formats and file formatting, because the model takes some files. Also extracting irrelevant data, because sometimes you get a lot of files and it's hard to find where it is what you need, or you need to extract from some big files some small parts, etc. And also you need to repeat many of operations, because sometimes you get new data, additional data, and then it takes a lot of time. And this is actually the most time-consuming part of all modeling, and also multiple tools what you get to work with certain, like GIS data, certain, let's say, okay, I forgot the names, but anyway, they are different formats, and we need many tools. So we were thinking. And also in SWAT, you see in this, there's plenty of data, and this picture prepared by Brig is very nice. Just summarize all the different type of data, what we need in GIS, time series, parameters, and so on. So to start model and make it running, you need to, how to say, search a lot of sources and compile a huge database of different stuff. So we kind of thought how to help and to unify our approach in the OPTAIN project. And so we developed many packages to help our case studies to follow kind of same path. So this kind of ecosystem developed, and of course this in how to say, highly how to say, inspired and made available by Christoph, and also others joined, and so now you see many packages in our ecosystem here, and also there are some additional which are not yet here. But so basically, at beginning, Misha told what the builder is the one to start the building your setup, but also preparing your data, the prepper, which is also prepared as a separate package, can be useful. So basically allows you to do many things. So just, I mean, what we had done with this package, and it's already available for you to integrate in your work, so you can find this package. And there's also Git page, which explains and also have all this newest version updates on this. So you can look into this link, you can open, you can install it, and so on. Everything is explained there. And also we prepared the article, so it's also in open access. You can download it, read it about this package, and hopefully understand if it helped or could help you, and you can start using it. So basically what you get with this package is specific functions. What it does is loading data from templates like Excel templates. You can load files directly from model files, or you can load the data from some internet databases, plot the data, calculate certain input parameters, data, prepare SWAT model input files, and update the model setup with these files and some extra functions which could be useful. So on the right, you see what is actually menu there already at this moment, but we are developing it, how to say, debugging and so on, and this is a work in some progress. So just few examples quickly to show what you get there. So one, let's say soil parameters, Brigi already told you about the details, but basically if you have some basic soil information about the soil depth, granulometry of each layer, and organic carbon, you put into the template, and you get all the rest of parameters related to what you need to run SWAT if you don't have these parameters. Another example is basically if you don't have atmospheric deposition values, you basically use these two functions. One, where you put your shaped file of your basin, and it downloads for it the data from IMAP server about deposition of different nitrogen, how to say, forms, and also adds this another function to add into your setup. And so the model already recognizes these values in the way you want it to add. If it's like annual values or it's yearly values and so on. So I think here I finish with this part, and I will join you a bit later.
Thanks. So now the third challenge will be shown by Michael. It is how to be sufficiently detailed with your crop management. And after this challenge, there will be possibility to ask questions.
Mm-hmm. So this challenge is directly related to this input preparation challenge. Also, your crop management needs to be sufficiently detailed. And again, to explain a bit more what actually we need in OPTAIN, in our model setup, we need a representative, that means a typical for the region, typical crop management for each field, for each individual field, yeah, for each of our routing units. And this we need for a long simulation period, because we also want to address climate change. And to do climate change impact analysis, we need long simulation periods. Also, for the historical period, we can try to be as realistic as possible. And you see in the map, each field can have a certain crop, and this changes, of course, from, is the animation working? No, I don't know why.
No, it's not running.
Okay, anyways, we need actually crop rotations in each field. And SWOT modelers among you would know, okay, with the new SWOT Plus version, there is this opportunity, this possibility to use decision tables to define the timing automatically when running SWOT, when should which agricultural operation take place. We rejected this option in OPTAIN because we have so many fields and so many operations we want to consider, long simulation periods. It would blow up the computation time. So we decided to use fixed operation dates. We have to define the dates for each management operation as an input, yeah, for the model. And those dates should be defined in a clever way. They should account for rainfall. No fertilization or tillage, for example, after a rainfall, or when there is a heavy rainfall event, because your nutrients would wash off in reality, and they would be also washed off in the model. Yeah, and this leads to unrealistic model behavior. And to do that, to define all these operations and the dates, we needed a workflow to write all these long files. So this is a little dry now, this chapter. One part of the solution is the SWOT farmer, another R package Christoph developed. It's a pre-processing tool, yeah. It helps to define your management input. Also for older SWOT versions, not only for the new SWOT Plus. And it is based on user-defined management tables. So it needs some information, of course. And the user can also define rules to control the timing for the operations. For example, this rainfall constraint. I don't know why I have this green thingy here. Do you see it as well? No, yeah, I don't know. The full solution is a bit more complex, yeah. The SWOT farmer package is just one part of it, the final part. What you need to run the SWOT farmer is a SWOT project. The txt in out folder is the so far built SWOT project. And we had already this, how we prepare it. We use the builder together with the SWOT prepper. You can use the full OPTAIN R workflow for that. You would have this txt folder. And the farmer needs this management input table. This is a CSV table, and it can be super, super complex, super, super complicated to write. That's why we developed an R script to do that for you. And this R script is also within OPTAIN's full workflow. But still, this R script needs input. And what you need to provide is first a land use map as a shapefile where you have all the different fields included, agricultural fields, and for each field a sequence of crops. Yeah, the crop rotation sequence for each year. And then you need management schedules for each single crop that can occur in this sequence, and also some generic schedule. I will explain now. So the shapefile looks like that. Yeah, this is the attribute table of the shapefile. This is your land use map, and there you also have your different fields. And for each fields, you have lots of columns with the year. And we need a sequence of crops. These are abbreviations of the SWOT model. Winter barley, winter rapeseed, winter wheat. This would be corn. It would be hard to get a 30-year crop sequence observed, almost impossible. But what you might be able to get is a crop sequence at least for a couple of years. You can get this from local data, and some case studies in OPTAIN were quite lucky and got those really observed crop data for the fields. Some case studies were not lucky because it's often data protection issues, but then you could use what Rigi already introduced, the OPTAIN crop classification tool. And this sequence you just extrapolate or repeat. Of course, it's not the observed sequence, yeah, but it's the best guess we can do.
Miha, you have 3 minutes left.
Okay, and then for this would be the land use map for the German case. For each field, you have a different crop in each year. And for each of these crops, you need now to present a 1 year, just 1 year management schedule. Yeah, this would be for winter wheat as a cash crop with normal tillage. And we define the operations like fertilizer, tillage, when is it planted, when is it harvested. It's the SWOT language already. Look up the SWOT documentation and also look in our documents, the modeling protocol, for more information. Important is that you define at this stage in these 1 year schedules that you define intervals, like 2 or 3 weeks intervals typically, when an operation typically happens, yeah? You also have to define a generic management CSV file. Here are the generic land use classes, like meadows or like forest. With generic, I mean, here we don't have a rotation. It's repeated every year, is the same happening. This is in the other CSV file. When you have all together, then you are fine. Then you can run the workflow. First, you run this R script. This combines the single 1 year schedules to a full crop rotation for your whole simulation period, and it will solve date conflicts. It's very likely that some operations will overlap when you put together single crop schedules, yeah? And these overlaps will be solved automatically, and everything will be written into the format this what farmer needs, and then you get these input table for the farmer. It looks quite complex. It has 200,000 of lines in our case, in the German case study. And here again, you have this time interval for the operation date. There are rules included, and you see it's all quite complicated to write, impossible to do manual. It's possible, but it's so hard. Use our scripts and you have the input for the farmer, and then the farmer is in the end only necessary to schedule the operation to a fixed date, a certain date, and write your SWOT plus model files. Then you have this super complicated detailed crop management in your SWOT model setup. Okay, I think I'm done with this dry topic. It's super painful always, the crop management, but it's important. One of the strengths in SWOT to simulate agricultural practices.
Thank you. So now we have time for questions. So please maybe raise your hand or write question into the chat.
Yes, and feel free really to ask questions, even if you don't think that that is maybe the right question, since this is a very complicated topic, I would say, for the people not in the modeling, and maybe even for the people who are in the modeling. So if you have any questions, feel free.
One question popped up for me, Brigi. Maybe I can also ask if there's no other question.
Okay, yeah, okay.
Yeah, this nice workflows for if there are data gaps, missing soil information, or the crop classification. Is it only useful for people working in Europe?
The methods are Europe specific. Usually, many of them could be used in the temperate region, but so the user always have to be sure that that he or she is using the local specific solutions. Yeah. So I would say that it always has to be sought which method to use, but it is an example workflow. So, and as an example workflow, it can be used anywhere.
Mm-hmm.
So there is a question. So I don't have clear when is it possible to use the SWOT plus editor. Is it directly after the SWOT builder, or is it also mandatory to apply the SWOT prep air? It was asked by Lorenzo Villani.
Yeah, no, it's the first thing. You can directly use the SWOT editor then after running the SWOT builder. But you need to, for the SWOT builder, you need the input data, yeah, the vector data, land use map, and also a soil map. And the soil map must come with all the soil parameters, with this database, the user soil, so it's like a circle. Yeah, if you have gaps or problems to derive soil properties, you can use the prepper to do that for you. But after running the builder, you can use the SQLite, import into the editor, and do everything then just from the editor. Load in the weather data and do other settings, and then press the button and write the SWOT input files. Was that clear? Yeah.
Yes, he writes, great, thanks. Okay, there is another question. How did you access the data for the crop management before this workflow was developed? And also how farmers are communicated? Is there a freely available database or tools? So maybe we can give examples. So for Hungary, to know the crop management, we contacted farm advisors and also requested reports from the farmers, because in Hungary they have to report when what was done, each steps of the management. Freely available data sets that therefore we didn't try to find. I don't know, for others, how was it?
Yeah, the management, the operations for each single crop type, you have to guess a bit. Of course, you can go out to the field and ask farmers. Brigi mentioned it already. We have contact in our multi-actor group. We have contacts to farmers. Farm advisors are super helpful. They have a broader picture. They know many farmers. They can help you. But often it's better to get something from literature also. How is it typically done to grow wheat or corn? What are the typical operations? What are typical operation dates? And then go and ask the farm advisor to confirm it. Also, the amounts of fertilizer, the type of fertilizer. How was it done before we had our workflow? I mean, we were just much simpler, yeah? Often, typical SWOT modelers just have a very simple crop rotation considered in their model. Just 2 or 3 crops. So the schedule you have to define is not so difficult. And maybe this was applied everywhere in the basin then. And it's not taking into account individual fields, crop sequences, crop rotations. It was just super, super simple. And it could be even so simple that there is just one crop all the time on the field. And in the end, you have in the catchment statistic, you have the crop shares, but what happens on the field is not super realistic. Yeah. With our workflow, we get a little better now.
Okay, we hope that it was useful for you who asked the question. Okay, and there is a question about the modeling. So maybe yeah, you could check the modeling protocol, the availability of it we will share, and you will be more familiar with this all if this was the question by Tabello. If not, please specify it a bit more. So no more questions on the chat. Maybe we can go on. So then let's see the fourth challenge. which will be presented by Svayunas. This is to ensure reliability in our model's results.
Okay. Well, hope all is well seen and you can hear me.
Yes, and we can
Yes.
see. Yeah.
Okay, so Misha told a lot about how we set up model and so on, and we arrive at one point which is quite nice. We have our setup, and then, I mean, of course, we want to do our work, produce some numbers, knowledge, and so on. But there's one important thing which is very crucial, is to make sure what your model output is actually reliable and what you can use it without a fear what you will get some results which would not be possible to explain, or without any kind of logic. So in our project, we put a lot of attention into this thing and developed a big kind of workflow and many ideas how to make this to make sure that our model works as it intended, and what we can have trust in our simulation results as well. So this many steps, and for these many steps we developed some tools, and so basically one kind of new ideas was developed for looking into model processes. So we called it model setup verification, so different kind of steps. Then of course we looked into how the best to calibrate models. So it's like starting from soft calibration of crop yields, water balance, and then hard calibration, and what options we have and how to do it in best way in consistent manner. So for different parts, we developed some tools, and actually, so for model verification, for model setup verification, we developed Smart Doctor. For calibration tasks, we developed a tool called Smart Tuner to tune your parameters, and they both use Swat Runner because this is the tool to run the model. Just before I start talk about this workflow, so just to mention what this runner is. So basically, it's two functions, maybe other as well, but these are the core of this package. But these are very powerful functions. So in one, you define what outputs you want to see. And in another, how you want model to be run, and you can also parallelize it and so on, add different kind of parameter changes, dates, and so on. And this you can do in scripted workflow, so you kind of update it. And this, how to say, this helps to run calibration, always verification, also scenarios, and so on. So this function was very, very useful for us. So anyway, going back to after you finish your model, setting up a model giving you outputs, usually the steps are you go to sensitivity analysis, calibration, validation, scenarios, reporting, and in the end you kind of find the numbers you thought would be great, but actually in reality you look what you cannot explain them, and there's a lot of problems. And so to avoid this kind of situation, on the right side, which you see, we developed kind of, okay, I'm sorry for this. We developed the kind of new concept, model setup verification, and it just goes after your model setup preparation. So basically, I will explain what it is, but actually what we develop now and what we want to share. So now is available online with a package. This is called Smart Doctor, and which help to do all these things. And also we wrote the article to explain all this concept and how it is used and how it should be applied, and all the guidance for kind of using this package. So yeah, you can access it and you can read it and familiarize with this tool, with this tool, and also ideas behind it. So anyway, so what it is with our model setup verification? Basically 5 steps where we can first look into all weather inputs and also water fluxes, what model simulates, and if there is any issues with that, then we look in the management, how it's being put in the model, and if it's triggered in the right way, how we expect them. Also, in next step, we look into a plant growth and plant growth without stresses. And so if the plant growth makes sense, and different plant growth parameters as well, we assess when we look into plant growth, deep stresses when we activate, the nutrient stresses when we activate, other stresses like temperature, water, aeration, and then the last step is looking into simulation of points of inputs and tile drains, if they are working properly and they are simulated as well in the model. So, and for this, we have this, which I already told you, the doctor tool, and for each step we develop different functions which help to look into the issues and also give some guidance in each step of this model verification, model setup verification workflow. So anyway, so just few examples maybe to show, so you get the idea what you can get. Let's say, just basically after you run the model, you just give some function, your output, and you basically get different kind of outputs. This one is for water flow, then you get for this HIU, what kind of issues can be with each HIU. You can also look into the stressors for each crop, what you have, how they are affecting your plant growth. I mean, each crop. You can look specifically into each HIU, how the plant develops, and like biomass, yield, leaf area index, and other parameters. And on top, you can see what specific HIU, what rotation it has. Yeah, and you can also look into how each stress group affects your yields, how they are reduced, does it make sense, and so on. In article and also in protocol, we provide the guidance how to actually do this in sequential manner and to kind of understand the issues and how solve them. So I love this picture. It's actually explains why the doctor can be useful sometimes, even it does not make sense. You want maybe go first or go straight to your results and save this step, but actually these things. But in the end, this procedure and this kind of workflow helps to eliminate the errors at the early stages. So you're basically saving a lot of time in calibration, validation, scenario runs when you discover some problems are not working with your processes, which you try to overcompensate with kind of calibrating of parameters and so on, but you wasted all this time, and in the end you see what there was some issues with some errors of input data, or some process was not properly implemented, and so on, and you need to go back and redo all these things. And so this thing, I mean, checking the processes before going into calibration and sensitivity and validation, it's very important to save you from some terrible things later. And also, it's important for building the confidence with the stakeholder, because you can go to your stakeholders, provide results, and if they ask some questions and you have no answers to that, I mean, the confidence, it's really the most important thing you can have. and if you lose it, you it's very hard to gain it back. So also it can be easily to integrate with templates, so you kind of can script all the steps, all this verification, and so you don't, if you update model, you don't need to kind of think what you need to put and so on. You can just script all the way and get all the outputs and check it again if everything is working well, if there's no messed up things. And of course, these functions help to investigate issues more and find what does not work, why, and you can adjust these functions to kind of understand a bit more. So now I will continue with this calibration thing. I will try to make it short. So basically, this SWAT tuner is the tool to help for you, and you can see the main kind of blocks of it, how it is proposed in our project. And so this package is already available. You can access it. You see the link and you can install, and also the articles. There's kind of guidance how to properly do the soft calibration for crops, for water yield, run calibration, plot result, and extend it for different kind of maybe optimization criteria and different kind of variables, and then you go to validation. So what you get with this package, it actually runs and SWAT runner, but there's a workflow and a guidance on this website, how to do this calibration, what to look, how to make how set your parameters and so on. Also some functions which calculate performance metrics, and there's many ways to adjust them. And also a lot of visualization options and also some analysis, so like dotted plots and interactive time series, parameter identifiability plots, one at the time analysis plots, and also different comparison for calibration validation. And also you can basically, after you've done your calibration, you can prepare with some functions calibration cal file, which is needed to place into your model to actually have a calibrated model. So, and also quality assurance workflow, which is in process. So basically you just run it to make sure, the idea to make sure what's your model after your calibration as well, or even before, it does not make any kind of your calibration mess in the modeling of processes as well. So
Jonas, we have 3 minutes left.
okay, I need to be very fast. So there is one example of soft calibration of crops. Then this parameter is very important, days to maturity, and you can see the output. You can just put your observed yields and basically varying this and other parameters, you basically get into the right kind of gap. So basically, in the end, you make sure that your yields at beginning with soft calibration are simulated well. They kind of represent what you get in the observed values. And also we have put two options for hard calibration, one in sequential order. So when we start from flow and we go, after we finish with that, we go to the sediment and with nutrients and so on. And other option which we present in this is like we put everything at once what we want, and then we work with all our variables and all our parameters at once. So just few examples, what you get is like some different outputs. This is just how one parameter change affect all the variable time series, and most of the figures have some interactivity as well. And this is, for instance, this example show how changing each parameter affect your model effectiveness for each performance index, and force, which I wanted to share. So now we have a SWAT calibration validation fully scriptable in R, and we kind of try to unify across multiple studies. So this kind of workflow allows you to not to fall into some kind of pitfalls, but kind of follow the path of which is I think we think it's the most reliable. Then of course it's saving time. Documenting and correcting is easy because it's all scripted, and it's easy to extend to multiple objectives. It's also fully parallelized. So we provide this package and website, so you can find always the newest tools and guidance here. And also it's already tested on 2 projects, and we are going to use it for more. And some additional capabilities will be soon, and hopefully we will prepare articles so other people can, how to say, get idea about this even easier. So I think I'm done. Hope in time.
Yes.
Thanks. And now again, Michael, with the 2 challenges, both are related to the small water retention measures. You are muted, Michael. You are muted.
Okay, so finally we talk again about the retention measures. The situation is we set up our SWOT model, we verified that the input data are read correctly, and we calibrated the model for stream flow, for nutrients, and now we are ready to use the model for scenario simulations. And the scenarios in OPTAIN are, of course, simulating retention measures. And what we need, again, in OPTAIN is a situation like that. We have a watershed, and we have already in the land use map included our retention measures. For example, here is a hedge. Here is a grassed waterway. And we know on which fields can be management changes, or we know about the scenarios. And what we need now is, and what we want to know in the end is, we want to see what happens for some environmental performance indicators. Like if you have phosphorus, soil erosion problems, what happens to the phosphorus loads? What happens to the soil water content? What happens to agricultural production here expressed as grain units? Or what happens to the low flow? And so we want to run lots of simulations with many scenarios. Yeah, we want to be very flexible in OPTAIN because we want to study the spatial effects of the measures. So what we need now is a tool that can flexibly implement the measures, for example, riparian buffer or low till on the fields in the SWOT model setup. That means writing SWOT files, rewriting them, and then SWOT is running, and then we extract the outputs. We need a situation like that. Yeah, we want to be very flexible, run lots of different combinations of scenarios, and want to study the environmental performance of all possible but feasible combinations. The solution is called SWOT Measure, another R package Christoph developed. And it's very useful to implement BMPs or NSWRMs, in our case, in SWOT plus model setups. I won't be too technical now. Still, it's technical. But if you want to have a more technical introduction into the SWOT measure, look at the SWOT conference presentation from Christoph. It's a video only available. But for now, I want to show you at least the full workflow of the SWOT measure. And for you, it's very important to understand there are 2 different steps, actually. One is setting up a project, a measure project. And the second is you can use this measure project anytime later to run model scenarios, and very flexible model scenarios. So, but first you need to set up such a project once. And for this you need, of course, your SWOT model, txt, an out folder. Just define the path. This is already the R code. Then there is another function where you have to define the path to setting files, CSV files, where you do some parameter settings for your measures. And you need a CSV file with the location. Where are those different measures possible to implement? Where do you want to evaluate it with your model? And then you can load the measure project anytime. It has all those informations. You can load it anytime and you can just implement those measures, and you are flexible then. You can define which locations, which individual measures should be activated and which not. Yeah, measures that are not activated, for those, the status quo land use will happen. And then you can, the SWOT measure will write the relevant SWOT plus input files, and it can be quite hard to, because you have to, they are all interlinked, the input files, and there can be many errors you can do if you want to simulate measures yourself in SWOT plus. And you can run it in a loop, so the measure is very useful. Just one more coding advice. This would be the R code to install the SWOT measure package, and this loads it. Yeah, and useful also is if you work in R, and you have to work in R if you want to use our tools, and you use the SWOT measure to write the SWOT inputs, you can then just run SWOT plus within R with this system function, and then name your SWOT executable. Okay. To talk a little about the input data needed for the measure to set up this measure project. These are the different categories of measures you can define, or you can implement with the measure: management, land use, wetlands, and ponds and constructed wetlands. And for land use, oh no, I will give you an example for CS1, for our German case studies, which type of measures we consider. Low tillage we consider combined with cover crops, and we know where are potential implementation sites. We discussed this with the stakeholders.
We had 3 minutes left for this challenge.
Okay, so I'm a bit faster now. Detention ponds is another measure. We have some potential locations: crust waterways, unerosive slopes, crust riparian buffers, where we saw there is no buffer existing in the current land use, and hedgerows, where we thought it makes sense to subdivide large fields. And now what is needed as input for the SWOT measure, you need to define the settings. Here the example category land use would include measures like buffers, like hedges or crust waterways. And what you have to define here is what would happen in terms of a change, in terms you want to implement it. What should happen in the model? Which plant community should be implemented? Which management? Yeah, it points to a certain management in your management file. Which curve numbers do you want to apply then? And which conservation practice factor, the usual p-value? Which Manning's N for overland flow parameter value you want to have. So these all points to different parameter tables, and you can define which here. You can also say, I want to deactivate any tile drainage that I had in the status quo in this HRU. Another example for ponds, where you have to define the dimensions of the ponds. Also, what is the channel where you send water from this pond that you want to implement? All the ponds that are implemented as a scenario, as a measure, must have then a connection to the channel network. You have to, these kind of input tables you have to prepare for your measures. And then you also need to prepare a location file. Where are the different measures? Each individual buffer strip or crust waterway give the HRU ID, the HRU name from your SWOT model setup. Yeah, this is what you have to provide, and then you can use it. And if you want to read more on how to use it, this is highly recommended to have a look in the Common Optimization Protocol. There's a whole chapter on this measure, how to use it, and lots of things to consider. Example results, this would be when we applied the measure for single scenarios. So each color a different. We just looked at one measure type and implemented all of these type, or we implemented all at once, and then we have different outputs for the water balance, flow outputs, stream flow, what happens to maximum and minimum flows, what happens to groundwater recharge or soil water compared to the status quo without measure implementation. Stuff like that. I don't want to interpret the results now, but for any kind of scenario analysis, the measure is helpful. And here would be a spatial map of running the scenario, all measures implemented at the same time. So I'm over my time already for the first block. That's why I have to go quickly to our last challenge. And this is the optimization. For multiple objectives, optimize the allocation, where to implement which measure. And because we consider multiple objectives and we do not want to weight the different objectives, like what is more important, agricultural production or water quality or biodiversity or costs or whatsoever, we end up in many optimal solutions, so-called Pareto solutions. That's why I want to give you the concept, some background information on the concept of Pareto optimality. It's a very old concept, goes back to Wilfredo Pareto, an Italian economist. And the concept is widely used in economics. The aim always is, if you have multiple objectives, to find solutions along a Pareto frontier. Yeah, and the Pareto frontier is a situation where you cannot be better in one objective without compromising the second objective. You always have to accept this trade-off, but you have to find this Pareto frontier where this situation happens. So everything what is inside the frontier is considered inefficient, and what is outside is considered not realizable. And we want to explore this situation when we apply it to the landscape research. The typical aim is find Pareto optimal land use management configurations in a landscape for predefined objectives like production, water quality, water quantities, soil moisture, or biodiversity. And you you can run, and this is the nice thing of modeling, you can explore many things. What is the situation with the current land use, and what would happen if we just run the model for different scenarios, yeah? And in the end, we are interested only in the Pareto solutions. Pareto solutions are useful, we believe they are useful in decision making because it really shows the potential. The potential a landscape can fulfill, the potential a landscape has to fulfill the different objectives. It shows at the same time the best possible trade-off among the objectives, yeah, the minimal trade-offs. And with this kind of solutions, you can then go to stakeholders. Each of the stakeholder groups, different sectors, they might have different visions, different preferences, but this is then very interesting. And can we find a best compromise solution then? Yeah, and I think in this way it can really support planning processes across different sectors. And what we also do in OPTAIN, we have this challenge of visualization. When we have more than 2 objectives, it won't be just a line anymore, the Pareto curve. It will be, the dots are not on a line, they are organized in a cloud. These are also Pareto solutions, not from this project in OPTAIN, from another project, but just the idea is shown here. And these are the typical objectives we want to consider in OPTAIN. In the end, I will also show you some results. So the key research question is where to implement which measure to fulfill the various environmental and economic objectives, identify Pareto optimal solutions, and then also this post-processing. How to visualize these, what looks super complex, how to visualize it in a way that stakeholders can digest it, that you can have a nice discussion on where to implement a measure. It's really a challenge. Each of the dot represents a different situation of a measure combination. Yeah? So we need some tools for filtering, clustering. We have to post process and then go in dialogue, have some interviews, talk about preferences. To be technical again and show you how you can use it, Comola is the name of the tool that links the things together. It's the first time now in OPTAIN that we use Comola with SWOT+. So this publication here would be an example of where it's used with other models, not with SWOT+. But this is how it works, yeah? You run lots of model simulations with SWOT+, for different allocation maps. And you have the SWOT measure to write the input for the SWOT+ model for each of those situations. And you have many situations, yeah? This can be a population size of 100 models will run each different inputs. So you will get 100 times these objective outputs, water retention, nutrients, some performance indicators. And these results from the SWOT model will be sent to a genetic algorithm, the NSGA we are using. Not the most modern, but it's still robust and does the things for at least 4 objectives. It would then apply a non-dominated sorting, a Pareto ranking, and the best simulations would be selected and recombined. And with this recombination, you create new offspring, which is in our case, new allocation maps, different measure combinations. And again, this goes in a loop over 200 generations. So in the end, tens of thousands of situations are tested, coupled with a genetic algorithm to make sure it's a clever search. Yeah?
Miha, you have 3 minutes.
Okay, thank you. And just to explain you how this, because you need somehow communicate. The genetic algorithm should communicate how to change the allocation maps. And this is the way how we do it. We encode a land use map as a genome. So the genome is just a string of numbers. And in OPTAIN, very simple. Number 1 means scenario is off. Measure is not activated, status quo land use for a certain HRU, and 2 would mean scenario on. Each position in the string refers to a specific measure at a certain location. And this is exactly the ID we have in the location file for the SWOT measure. So in this way, it's super easy to flexibly implement the measures. This are the genomes from the genetic algorithm. If no measure is activated all once, if all measures are activated, it would be all a 2. And then you have this recombination going on. So imagine these 2 genomes, which represent maps, or maps which lead to a good environmental and economic performance, were ranked high. So these are selected for mating, and then there would be crossover applied. Yeah, you see how they are combined, and there can be mutation. And in this way, the genetic algorithm works and suggests every time new implementation maps. You find the Comula SWOT Plus application on GitHub. And just because the time is out now, but this is quite useful to know. If you download from GitHub, you will get such a file structure, and it's mandatory. Don't change the file structure. All the folders should be the same. I mean, there are many folders and many files, but only a few you have to change. What you have to change, I inserted this star. So you need to have your own SWOT Plus model, and it should be calibrated. It should be fully parameterized with proper printing settings. Only print what you want to optimize the output, yeah? And you need a SWOT measure project, and you should have tested the plausibility of how measures are simulated. You need, if you want to consider costs, you should adjust such an Excel file for your, with some economic parameters. And then you have to go into an R file and have to adapt it for your own optimization objectives. You are completely free, and we offer lots of different opportunities. Then you need to configure this config.ini file. It needs to know where is the path of your R and where is your Python. This needs to be installed on your system. And then you give the path to those executables. You define the pop size and the number of generations. And then you can just click on the Run Comula button to start the optimization. Again, you find a very detailed protocol in this optimization protocol. And here an example of our very first OPTAIN results, optimization results. It looks quite interesting. Yeah, we have the costs here, and this is a reverse scale, also reverse scale for the phosphorus loads. And what you can see, there is a trade-off. Of course, the more you want to reduce the P load at the outlet, the higher are the costs. But it's absolutely not linear. You can be very efficient with smart combinations of measure implementation. And as time is over, I thank you for your attention and would now go to the question part.
Thanks. So as Ivana wrote already, just feel free to put your questions into the chat box or yeah, raise your hand. Okay, so it is one question for Svayunas. What is the reason why you have not considered yearly crop yield, not annual average, in your workflow? Also, is it possible to perform hard calibration for yearly crop yields with the SWAT tuner? And then there will be a question for Michael, but maybe first Svayunas.
Yeah, it's a good question, and I have not really I don't have a good answer now, but yearly is not possible. We put average, like a kind of statistics. I think it's not easy to match the yearly because there are many things, but with soft calibration, we want to match at least the average, but it's going how to say, it's on the right level, because the soft calibration of yields, maybe it's not the purpose of the model. We just want to make sure the model have the processes right, so it gets on average the right kind of answer. I don't know, maybe Nikolai has more ideas with this, or Misha.
Jonas, it's not possible right now, but actually it's a low-hanging. I mean, I also see the point where it could be useful to be, if there were years where observed crop yields were very low because of some dry weather or whatsoever, if we can also see it in SWOT, and it shouldn't be a big problem to also have a time series plotted for every year crop yield.
Yeah, you're right. This is I mean, we need to put some work to be adjusted to include the yearly. It's not how to say, nothing extraordinary. But so far we did not really had this question, so we did not implement it.
Yeah.
Okay, then a question for Michael. How did you simulate mulching in OPTAIN?
No, there is this hard calibration with yields. Oh no, yeah, the mulching. Oh, mulching. I'm. It's not. To be honest, it's not considered properly mulching. What we did with our low till scenario, it's reduced tillage depth, of course, and mixing efficiency. But we also changed the parameters for curve number. The curve number we reduced, and also overland flow. I mean, if you are interested in the settings, in the real parameter values, how we changed it, please write me an email. I will then send you some details. But we reduced those parameters as well, just to make sure that there is more infiltration But actually, what you should do, and when you want to simulate mulching, you should increase the residuals, the residual cover. Maybe we have more of the residuals left over in the management schedule for low till, but I'm not sure about that.
The simple answer is that I think no one actually tested mulching, so it was on the list, but none of the case studies so far really applied it.
Yeah, but it's often, if you do reduced tillage or no tillage, you often have mulching together.
Yes, so we had no-till and there is mulching. So I cannot tell you now exactly how we set the parameters, but the land use loom parameters had to be set. So we tried to select from the default values the one which is closest to our situation. Yeah. Okay. Then another question that if Emmanuel Escobar wants to consider some burnt areas, do you recommend to put this as operation management in the SWAT farmer, or to create a new scenario?
Oh, it depends on your how your SWOT model project looks like. I think I'm not sure if there is a decision table already existing, a default decision table provided by SWOT Plus to do a fire operation. I think we have Natalia also here in the audience. Maybe she knows if there is this. There is a burning or fire. I never simulated fires, but then if you want to use decision tables or our SWOT farmer approach, this depends on how detailed your model should be. If you have thousands of fields with lots of operations, I did this test, maybe my decision tables were not smart enough, but when I use decision tables to simulate operations, to decide for the dates for the operations, it was it took such a long time. Computation time just blew up. So you could perhaps use the farmer, but I'm also not sure about that. I don't know if Natalia is here. No. So, and
We have to move on to another question because they're coming.
Yeah.
Mm-hmm. Okay, so the next question is, there is a lot of spatial components whereby the temporal factor is variable. Some of the examples shown has parameters reported annually, monthly. Does this mean the data or specific parameters obtained depends on its availability? Is there any YouTube channel that we can learn from? Because she's not really experienced, so that's why I ask. Yeah.
Nikolai, this is an abstract question. You did the abstract part here.
Okay, we're talking about different time steps for different maybe model inputs, and I think the model can handle it somehow because it's really up depending on the data availability. For example, speaking about point sources or atmospheric deposition, you have the choice to use the average annual inputs, the annual, the monthly, or daily. Another temporal component is your calibration. Again, here you have the free choice to focus on whichever time step you like. But the model always runs with a daily time step. Well, unless you are using a specific sub-daily routine that is not very popular so far. So, well, I hope it at least partly answered.
Do we have time for a last question, Ivana?
We are a bit over our time, but maybe one more question and then we should continue.
Okay, so it is for Michael, just for fast. Regarding Pareto solutions, do they usually straightforward to apply in practice? If not, is it possible to consider application feasibility or viability as an objective function in optimization process?
Our OPTAIN approach is we don't have any feasibility constraints. We just let the optimization algorithm decide where, I mean, it's free, it's completely free. But what we try to make sure is all of the different areas where a measure can be applied, it is somehow feasible. We did this before when we talked to stakeholders. But yes, if you could come up with some constraints, you could, if you are able to calculate for a certain spot in your landscape a kind of feasibility index or some barrier whatsoever cost, yeah, you could, of course, use this as an objective function, and this objective function's feasibility you want to maximize, or it depends how you, yes, it's absolutely possible.
Okay, so we are running out of time. So Mikolai could come with the wrap up.
Exactly. So I think I have negative time left. But I will be quick. As you could have seen from our presentation, we focused mostly on the approaches and tools, and you may wonder what about the results that the OPTAIN project delivered. Michael shown in his one of the last slides this nice Pareto frontier plot, and he interpreted a little bit, but there are already preliminary results. They can be found in our deliverables that are available on Zenodo, and final results for some other deliverables will be ready within next year, I hope. Maybe something for those who are considering, okay, which of these tools, approaches are applicable to me, which are not. I want to say that what we opted for, this harmonized and fully scripted workflow, is for us it was very attractive, and probably we still think so, but it's quite demanding, and you should not underestimate the support that is needed for, let's say, case studies that are less experienced, but also for scripting, finding bugs, and so on. Finally, scaling up. As you know, we focused on very small catchments. It's possible, but really major effort is needed for land object layer preparation in first place, and maybe a few other spatial inputs. I collected a few recommendations on the tool usage. So you have all these packages and so on, and most of them, as you can see, are really applicable to any SWOT plus setup, but with two important exceptions. The SWOT builder, I think it's really recommended, as for now at least, for small catchments, because it requires high quality input maps that I guess for most case studies are just not available right away. So a lot of cleaning of data is needed. Then the SWOT measure that Michael was presenting, it depends on SWOT builder and SWOT farmer. So unless you use the two, there is no point in considering that. And finally, the SWOT prepper, probably for some functions, it is a little bit tailored to OPTAIN or to European data. So, but the majority of functions should be applicable. And I also collected again the links to well, let's say the sources of all these tools. As you can see, they are spread across several GitHub or GitLab pages. One of them is still not fully, let's say, ready, but it should be quite soon. And finally, I mentioned that these deliverables OPTAIN Zenodo repository with a lot of materials, but I would just like to highlight our modeling protocol, point number 1, and a very recent report on assessment of effectiveness of measures, where several case studies reported the results on how effective the measures are, simulated effectiveness, and also the effects of climate change and things of this nature. Finally, I have this list with the speakers and emails in case you have some burning questions or something pops out when you start using the tools. Feel free to contact us. Thank you. That's it from me.
Thank you very much, Mikolaj. So I will just quickly share also to close the webinar. Okay, just to see. You see the screen? Okay. Yes, I just wanted to mention to the participants that you will be there will be additional chances to join additional webinars. There will be 3 webinars held also in 2025. One will be focusing on learning from stakeholders and what are the benefits of the stakeholder involvement in the modeling projects and the results we gained from the OPTAIN. Another one on supporting hand of policy, how the policy supports the implementation of natural small water retention measures. And then one more on the learning environment. So from learning knowledge to action, the optimization of solutions and support for further natural small water retention measures implementation. Because there will be also this online learning environment platform available where you will be able to access multiple deliverables and results from the project itself. So it will be available also next year. But yes, just that you know that there will be additional chances where you could join and learn additionally. And yes, we would like to thank you from the side of the OPTAIN project. And yes, also apologies for being a bit late, but I believe it was very useful. So yeah, and thank you very much all the colleagues. So to the speakers, I really enjoyed, to be frank. And also thanks for the participants for joining and for your time. Yes, so we end now. And just, yes, one more thing to mention, there will be, so on the OPTAIN website, we will have the webinar next week posted and all the presentations. So this week not, but next week, please check. Yes, thank you. Bye-bye. Have a nice day.
Bye-bye.
Bye-bye.
Bye.